This is Timothy Wood with Citadel Civil Engineering. This is CIVL202 Statics, and in this lecture we're going to introduce the idea of non-concurrent equilibrium. Just as a reminder, in statics we're learning concepts now so that we can use them in later classes. And by the way, this is the moment that we've all been waiting for. When people ask, are you any good at statics? What they mean is the content starting in this lecture. Can you do rigid body, non-concurrent force systems in equilibrium, analyze them, figure out their reactions? We're going to assume that you could do this in mechanics and materials. Your first step in mechanics and materials is going to be to do a statics homework problem, then start a mechanics and materials problem. So you're going to want to master this content now. So let's just look at this from the very highest level. You can see where we are in our overall system. We know what force vectors are and how to manipulate forces and vectors. We've learned about force systems that introduced moments. We've talked about particle equilibrium, which this is going to be an extension of, and our centroids have allowed us to both think about the center of gravity, center of mass, center of volume, center of area, as well as how to deal with distributed loads. And we're going to be using all of those things together to do rigid body equilibrium. So with this in mind, let's just put some basic concepts on the board in this video, and then we'll do some videos later to get this all together. So the first thing we need to acknowledge is that we're working with non-concurrent force systems, which means that our forces will have do not all intersect at one given point. So I might have a system of forces like this where we acknowledge that if we extend their lines of action, we'll notice that they intersect at a couple of different spots. Sometimes they run parallel to one another. We have non-concurrent forces, so they don't all pass through a single point. What this means is that we can now model bodies as rigid bodies, where we are concerned primarily about the body's mass and length or shape. So for example, I can take something like a meter stick, which is not actually rigid, so I can flex this body, so it's not actually rigid, but I could put it up here and I could model it as a rigid body with these forces acting on it. Like so. So then I could have my rigid body there with mass and length and a non-concurrent force system acting on it. And what this means for equilibrium is two things. Again, we're taking Newton's second law and we're reducing it down to actually Newton's first law, the law that says that for every action there's an equal and opposite. Nope, that's third law. Newton's first law says that for a body in motion or at rest, it will continue to stay in motion or at rest unless acted upon by an external force, or we might say the sum of the forces equal to 0. Yay, nothing moves. So we're going to notice that we're now going to have no translation. It's not, the bodies are not going to move left and right. This is all we had in particle kinematics, such that the sum of the forces is equal to 0, knowing that this is a vector summation. But we're also new to rigid bodies is that there'll be no rotation, and therefore our sum of our moments, meaning both applied moments and our force generated R cross F moments, our sum of the moments is going to be equal to 0 as well. So we're going to have these two relationships as our dominant features. When we're tackling problems like this, our procedure is just like it was for rigid bodies, for particle equilibrium. We're going to start by looking at the body, interpreting our results, our problem, and drawing a free body diagram. And then from the free body diagram, we're going to write our equations of equilibrium. Sum of the forces equal to 0, sum of the moments equal to 0. Given that, we're going to have a systems of equations that we'll be able to then solve simultaneously. Do our simultaneous equation solving. And that's it. So this is the basic layout for what we're doing. Now, in the next video, we'll talk about free body diagrams and the unique sort of reactions that go into free body diagrams for rigid bodies. And then we'll talk about our equations of equilibrium after that. I look forward to seeing you on the next video and then in class. Take care.